Hello everyone, and welcome to this presentation, which is all to do with differentiation from first principles. Now, as it says here, you can find the gradient by comparing the change in the y-axis by the change in the x-axis, and we did a lot of work on this when we were doing our straight line topic. So when you have a straight line, the gradient is constant. In other words, it is the same wherever you look at the points on the straight line, and it can be calculated using a gradient triangle. So this is a classic method of finding the gradient on any straight line. We choose 2 points. Doesn't matter where we choose those 2 points because we know we're going to get the same answer every time because the gradient is constant. So here is one example of how we could find the gradient on this red line shown. The formula that we have used many times already this year is shown here. But other functions that are not straight lines do not have a constant gradient. So an example of that would be this quadratic shaped curve that you see in the bottom left-hand corner. So depending on where you look on the curve, there will be a different gradient. The gradient is not constant. So for these functions, the gradient changes depending on the x value. So the gradient is not just a single value like it would be on the straight line. The curve indicates that the gradient is going to change depending on whereabouts on the curve we choose to look. But we can still calculate the gradient by finding what is called the gradient function. Now later on the course, after this presentation, we're going to be looking at how to do that quickly and efficiently. But in this presentation, we're learning why that method works. And the reason why that method works is taught using differentiation from first principles. So the process of finding this gradient function that we can use to find the gradient of any point on a curve is called differentiation. And as we've already seen, when you are working out the gradient of a straight line, this is the formula that you use. If we want to find the gradient function, which we can use to find any point on a curve, then the notation that we use is dy over dx, or dy by dx is how we sometimes say that. Now, you might not be given an equation. So if we are given an equation, for example, y equals x squared, then when we are finding the gradient function, that gradient function would be denoted as dy over dx. However, as we know, sometimes you don't get the equation, but instead you get a function, where the notation for the function is f of x. Well, if that is the case, then when we are differentiating, the gradient function would be written as f dashed x. Let's look at how differentiation from first principle works then on an equation that we have seen many times before, which is the equation y equals x squared. So if I do a little sketch of y equals x squared, we know that it looks like this. And we can see that the gradient is changing depending on whereabouts we look on that curve. So I've chosen my point. You can see the point that I've chosen, and the way that we work out the gradient at that particular point is by looking at the tangent of the curve at that particular point. And you will have done this at GCSE level. You will have been asked to physically draw that straight line on the curve, find the gradient of that straight line, and that is the gradient of the curve at that particular point, which is all right, but unfortunately is not as accurate as we would want it to be. It's very likely that if you perform that operation, you will get a different answer to the person next to you, depending on what level of accuracy you choose to give your final answer to. So although it's okay, it's not ideal. Whereas differentiation, of course, will give us an exact answer every time so that we can be more accurate with our answer. So we've found our x value, and what we're going to do is we're going to look at what is the x and the y value for that particular point. Well, our x value is x, and if I take that x value and place it into the equation, I get a y value of x squared. Great. Now what I'm going to do is I'm going to choose a different point on the curve, one that is just a little bit further on from the point I already have. So you've got to imagine that the difference in the two x values between the 2 points is very small. So this x value I'm going to call x plus h, where h is a very small value, meaning that the 2 points are very close to each other. And to find the corresponding y value, I need to take x plus h, place it into the equation, and I end up with x plus h all squared as my corresponding y value. And what we're going to do now is take a little bit of a closer look at this section of the graph where my 2 points are. And here it is. So again, you can see I've got my 2x values and I've got my 2y values. And what we're going to do is we're going to form a gradient triangle. The line that we have drawn, notice how there is now a line in between the 2 points. That line is called a chord. And what we're going to do is we're going to find the gradient of that chord. Now the gradient of that chord is not going to be the same as the gradient of the tangent line that I require, but it's not going to be far off. So as is mentioned here, look, there's my tangent line there. That blue dotted line represents that tangent line that I'm trying to find the gradient of. And you can see that the red line is all right. It's not far from where I need it to be, but it's not quite the same. But nonetheless, that's a good starting point. So let's work out the gradient of this red chord that joins the 2 points together. So the way that I'm going to do that is work out the difference in the y values, which is x plus h squared minus x squared. And the difference in the x values is x plus h minus x. And when you're doing this as an assessment question, it's often worthwhile drawing the triangle to show what the x values are and what the y values are. And we'll see that in action in just a minute. And so using my formula for the gradient of a straight line, I can work out the difference in the y values over the difference in the x values, and that will give me my gradient function, dy by dx. Now the first thing I'm noticing is that on the denominator, the x plus h minus x simplifies to just h. And you will find that this happens every single time you do a differentiation from first principles question. And it makes sense because the difference in x is just that little value h that we were talking about earlier on. In terms of the numerator, I have multiplied out the brackets. And by doing so, I can also see that on my next line, the x squareds are going to cancel each other out. And I am left with this as my gradient function. And again, another hint is that anything that does not involve a h will cancel. So you shouldn't be left with anything, any terms that do not involve h. So the x squareds have gone. And then the final thing I'm noting here is that I can divide the 2 terms in the numerator by h, and that will give me my near end result, which will be 2x plus h. So this is my gradient function. But as we said earlier, the gradient of this chord, which I've now found, is not quite the same as the gradient of the tangent that I'm trying to find. So how do I resolve that problem? Well, what I do now is I look to see what happens as h gets smaller and smaller and smaller. Because if I make that what was already a small gap between the 2 values, if I make that gap between the 2x values smaller and smaller, if I make h get closer and closer to 0, what happens is that the red chord line that you're seeing on that diagram starts to match up exactly with the tangent line that I'm trying to find the gradient of. And that's differentiation from first principles. And the way that we would conclude this question, in other words, how I would finish off my question and find the actual gradient function is I would explain to the examiner that I'm looking to see what happens as h gets closer to 0. And you can see the notation for it here. This is the notation that you would use, and the arrow means tends towards. So as h tends towards 0, as h gets closer to 0, it's going to mean that in my gradient function, the h gets close to 0, it disappears, and I'm left with the gradient function equaling 2x. And that's differentiation. I can now say that if y equals x squared, then the gradient function dy by dx is going to equal 2x. And it's this gradient function, 2x, that I would use to find any gradient at any point on the curve. I'm not going to be drawing any more lines to find those gradients. Good, so that's all good and well. We now can see the process involved in differentiating and how it works, but that's not really going to help you when it comes to answering an exam style question. So the final thing we're going to do in this presentation is we're going to look at an example of how you would write a model answer if you were given one in a test or an assessment or an exam. So by all means get this down in your notebooks, and then you can use it as an exemplar for any of the other questions that you do. So the question says, use differentiation from first principles to find f dashed x. So we've purposely used the alternative notation here. For the function f of x is 12x plus 8x squared. And then once we've done that, so this is part A, and then part B is use that gradient function to find the gradient when x is 2. So part B is actually very, very simple, because part B is going to involve just subbing in the value of x equals 2. So the majority of the marks are going to be for part A. And I'm going to show you the step-by-step approach to getting a perfect answer every time. So first of all, we are differentiating from first principles, and therefore we would write down the formula that we would need to do that, which is this one. Don't forget that it could be dy by dx equals, but I'm using f dashed x because of the function that I'm given in this question. So again, it's all about the difference in y over the difference in x. This will give us the gradient of the chord, and then I'm going to consider what happens as h gets smaller and smaller. So I would always, and you can follow my advice or not, I would always suggest that you do draw a little triangle just to show what's going on. So the first x value is just x. It will become 2 later on, but for now we're just looking at it in a very general way. So my first value of x is x, and my second value of x is x plus h, exactly the same as it was in my example question. In terms of my y values, if I place x into the original function, then I get 12x plus 8x squared coming out. And more importantly, and perhaps the bit that we struggle with the most on questions like this, is what will be the y value, what will be the f of x value if the x value is x plus h. And all I'm doing here is I'm taking that x plus h and I am replacing that into my function wherever I see an x. So I've now got, and once you're at this point, you're pretty much done and dusted, apart from a bit of algebra manipulation. This is the crucial part, because you've now got your 2x values and you've got your 2y values. So we can work out the gradient of the chord. So this is me just placing them into my formula. You can see that I've got the difference in the y values on the top. I've got my difference in x values on the bottom. And what makes these questions a little bit awkward is that we all know how to multiply out brackets and manipulate this algebra, but quite often we make mistakes. And of course we're gonna struggle if we make any sort of mistake when we are manipulating the algebra. So we'll do it in steps. So this first step is where I have recognized that h will be on its own in the denominator, which I've said to you before will always happen. And I've also multiplied out the brackets in the numerator, or I've partly multiplied out the brackets, and you can see the result of that. Work through that in your own time. Make sure you're happy with it, and if you're not, then ask your teacher about it. And I can simplify that numerator because I know what's going to happen, because I know the rule. Anything that does not involve a h is hopefully going to cancel, and I can see that that's going to happen here. The 12x minus the 12x is going to cancel, and the 8x squared minus the 8x squared is also going to cancel, leaving me with this. So that's nice. That's exactly what I was expecting to happen. And the final step that I can then do, because all of the x's have cancelled, the final step that I can do is I can divide the three terms in the numerator by h, and that will leave me with my final gradient function. But that's not quite the end, because remember, this is the gradient of the chord between the 2 points. What I now need to do is look to see what happens as h gets smaller and smaller and smaller. So the final step is to say what happens as h gets closer to 0. Never talk about h equaling 0. Always talk about what happens as h gets closer to 0. And what will happen as h gets closer to 0 is that f dashed x will equal 12 plus 16x, because the 8h will disappear. And that is my gradient function. Job done. Now, in the next presentation that we do, we will be looking at how to do this in a very quick way. How, if I'm given an original equation or function, how can I quickly find the gradient function? And so we will be able to speed up this process quite a lot. But you also need to know this idea of first principles as well. So that's part A done. I've now found my gradient function. And I would use this as an exemplar for any question that you do in the future on first principles. And then for part B, our final job is to find the gradient when x equals 2. So remember, depending on which x value I choose, I'm going to get a different value for the gradient. So part B is me just simply replacing x equals 2 inside the gradient function, and I end up with a gradient of 44. And that's it. So you now need to practice that using the skills that I've taught you and the exemplar that you've seen. And so I'd like you to have a go at this exercise on page 96. And in particular, if I was going to pick and choose, I would have a go at question 3, which is where you have 4 functions, 4 equations, and your job is to use first principles to find the gradient functions. So I would concentrate on question 3 if I was going to pick out relevant questions from that exercise. Any problems, speak to your class teacher. And I will see you for the next presentation, which will be all about differentiation using the shortcut method. Thanks for listening, and I will see you next time.